Welcome to Rising Above It. I'm your host, Nancy Seagal. Today's topic is mercury poisoning. And today we will learn the facts about mercury, how we're exposed to mercury, and how to prevent mercury poisoning. As many of you know, I am a mercury poisoning survivor myself. I was exposed to mercury through eating fish, dental amalgams, and also breaking a thermometer, and also vaccines as well. I also spent 12 years of not knowing what I had. I was paralyzed in a wheelchair at one point, and then I was finally discovered by a doctor. The diagnosis was made, and I spent another 2 years recovering from it. And today I'm healthy and happy, and now I get to share how I overcame my adversity. And today's we have a special guest, but before I introduce him, we're going to show a slide about a fact of mercury poisoning. And if we can have that slide brought up on the screen. Adults with mercury over 2 parts per million have a 69% greater risk for heart attacks and a 93% premature death rate. Also, Alzheimer's patients found to have high levels of mercury poisoning in their brain. And 8% of American women of the childbearing age that have mercury have levels that are high enough to place their babies at risk for birth defects, loss of IQ, developmental problems, and learning disabilities. Those are some startling facts and statistics, and that's why I'm honored to have our special guest here today, Dr. Keith Schofield. He is a professor at the University of California, Santa Barbara, and also emeritus, and also the president and CEO of Chem Data Research. And he also has been an inventor of mercury emissions technology. So welcome, Keith. Thank you for coming to be on our show today and sharing your information about mercury poisoning and mercury.
Well, thank you for inviting me. It's not often a scientist gets out of the lab and is asked these questions, but it should be remembered that I am a scientist. I'm a research scientist, and so I take a somewhat different approach to mercury. I am a chemist, and I've been looking at mercury now for 10 years, but whenever you do research, you get drawn into all aspects of it. I got into it 10 years ago by chance, in a way, in that I had finished one program. My field tends to, I've always been a research scientist my whole life. I've been rather spoiled, and I've always somewhat been able to decide my own topics, which is very, very unusual nowadays. And I was deciding what to do next. My field mainly is in the area of energy and combustion. The main interest in combustion for the last 20 years or so has been the emission control.
So emissions from coal-fired power plants?
Or from automobiles. I mean, we're now controlling automobiles to the point that, you know, you can no longer commit suicide in your garage with an automobile. It is
really?
Yeah.
Interesting.
And anyway, so I was wondering what to do, and I was always intrigued by the metals, the trace metals, particularly in coal more than anything else. And EPA at the time was very concerned. In fact, they always used to call them the dirty dozen. There were 12 elements that are toxic and are in coal. Things like cadmium, antimony, arsenic, lead, selenium, and mercury, and chromium. And in fact, I thought I might look at chromium because chromium was a lot in the news. And the thing that drives research nowadays, more so now, is it can no longer be purely academic, so you have to have some relationship between your study and what you're doing. But chromium was in the news. But at that very time, I received a paper from one of the journals, one of the scientific journals. When people publish in science, their publications are peer-reviewed, and they usually, the publisher sends it out to 3 reviewers, and I was supposed to review this Chinese paper on mercury. And it was a nice paper, but the problem was they were trying to explain what happened to mercury in a coal combustor, and the thing that the paper showed me was that they could not explain it. They were trying to what they call force fit the model that they were using to the data, which is a scientific no-no. So I found the paper very interesting, and it was very valuable in a way, because it showed me that there was something else happening with mercury that was totally was unknown, wasn't understood. So at that time I had the lab set up, and I am a little different from most others in this area. There's very, very few in this field, in fact, that I can look at metals in flames very, very easily. So I thought, okay, I'll just spend a few days, I'll look at mercury. And what this entailed was we can have research flames that we understand very well, and we really use the flame as a way to induce chemistry and understand chemistry. So what I would do, I thought I'll just do some basic experiments. I'll put some, I'll get a few parts per million injected into the flame, and then I will add things that are in coal combustors, like sulfur. There's sulfur there, there's chlorine there. So I did 4 experiments that first week. And my technique was not just to look at the flame, but what I would do, I would put a probe in the flame. And we have a slide.
Yeah. In a moment, we're going to show
we have a slide of the first experiments that I did. And the thing was, those experiments, which I don't know how I chose them, but they resolved the whole chemistry of mercury in flames.
So the rest is history. You've been studying mercury since then.
So that showed me exactly what was happening. And once you understand what's happening in a system, you can then devise a method of controlling it, and that's what happened. It showed me immediately how we could control mercury from coal combustors.
Great.
Now, so it's very interesting, because when I discovered that, I almost foresaw today. I almost said to myself, do I want to discover this or not? Because I could see the I could see immediately it has significant implications. And it showed us how to control mercury. And since then, we have tested this. We tested it last year in a pilot plant in Laramie, and it worked very, very well. And in a few months, we're going to do some really major testing at EPA in Raleigh, North Carolina, which will show whether it's commercially viable. It's a commercially...
So
and it's really, the main point of it is it's a very simple method. You're really helping the mercury do something it wants to do. You're converting the mercury into something that can be controlled.
Wonderful.
And
so what is mercury?
Mercury is a very, very unusual chemical element. Mercury is an element of the periodic table, but it's a heavy metal. Those that remember the periodic table from high school or whatever know you've got hydrogen number 1 and uranium 92. Mercury is actually number 80, so it's way down the table, and it's very, very unusual in its chemistry. One being everybody knows mercury as quicksilver. That is the element. The element is liquid. There is nothing else in that part of the periodic table that's liquid, especially if it's a metal. There's no metals that are liquid. So that factor that you have a metal that's liquid, it conducts electricity, and has various properties that it has, always made mercury very popular. And it was known, mercury has the symbols Hg. That's Greek. It's Hydra Argentus, I think. Hg, that's where we get the Hg. And it means silver water.
Okay, and so as a heavy metal toxin, or a heavy metal element, it's as far as humans ingesting it, being exposed to it, it's a neurotoxin for us as well, and it affects our cognitive abilities and as well as our nervous system. Correct?
It's always been known as a neurotoxin, and but you can't just generalize it in that there are one or two mercury compounds that are not toxic. One is the ore itself, mercury sulfide, cinnabar, from which we get mercury. And in fact, we have a mercury mine here in Santa Barbara at the end of Gibraltar Reservoir. There's an old mercury mine, which is really interesting to see. And but we say by the fact that mercury sulfide is totally insoluble. Otherwise, Santa Barbara might not exist. But the form of mercury is very important, and the beauty that the Greeks, the Romans love with mercury is it amalgamates with gold and silver. That's one of its main historical uses. And it was used in mining. I mean, the miners used to use it to extract gold and silver. And the dentists, of course, use it. I have mercury in my mouth as amalgams, but that is elemental mercury, and it's not quite as poisonous. It's not poisonous as some of the other forms of mercury, the organic forms, which you tend to get in fish, and we did have in vaccines. It's still present in some vaccines.
Yes. Okay. So let's go to the slides, and we have a few slides we'd like to share. You can share with the viewers the.
This was one of the very first experiments I did. It was never thought that mercury, since it's so very, very volatile, could ever condense on a surface. Well, that's just the opposite that was found. Mercury actually loves the surface, but it's got to be at the right temperature and the conditions. But in this case, there was mercury and sulfur in the flame, and this deposit is actually mercury sulfate. And it was deposited on platinum, which was not necessary, deposits on anything, but it was on there just for the photograph.
Okay, and then the next slide?
The next slide is the whole chemistry of the mercury.
And that's a little bit beyond most of us what we know, but...
But what the mercury does, it goes to the surface, it makes mercury sulfate, this HgSO4. But the thing is, instantly, some hydrochloric acid, which is present in the coal combustor, attacks it, converts it to this HgCl2, which is very volatile, and that comes off the surface. So it's a very elegant mechanism that mercury cannot react in the gas phase, but by using the surface, it goes on the surface, which are 2 dimensions. It does the chemistry instantaneously, and then it comes off the surface. So that's why people never realized there was surface chemistry, because it goes on and off, and it leaves the surface unaffected.
Okay, and then the next slide, please. Okay, so this is one of the facts I'd like to share with you. It's 1/7 of a teaspoon, or in other words, a gram of that's found. It's the same amount that's found in a thermometer. Can contaminate a 20-acre lake. The U.S. coal-fired power plants produce 48 tons of this each year. which is alarming. And so our lakes are being, and our waterways are being contaminated with emissions from the power plants. So the next slide, please. Okay, some of the sources of mercury and mercury poisoning are, as we spoke, power plants, which are electrical and coal-fired power plants, mining, waste incinerators, landfills, cement manufacturing, hospitals and crematorias, coal alkali plants. There's also a shipwreck off the Dominican Republic that in 1724, and it's still there, is 400 tons of quicksilver. So it's still in its liquid form. It's off the Dominican Republic. And then it's also found in aeronautics industry and submarines, and also it was used in World War II. As far as personal and household exposures, we are exposed to dental amalgams, which are the silver tooth fillings, vaccines, fungicides, light switches, fluorescent light bulbs, gauges, and even latex paint prior to 1991. Mercury can also be found in our natural environment, which we can find in volcanoes, earthquakes, as well as geothermal vents. And those are some of the natural causes. So no matter what, we'll be exposed to mercury, but at what levels? So my next question for you, Keith, is the government has released information on the well-being for pregnant women and children in regards to mercury exposure. Why is mercury still newsworthy, and do other people other than pregnant women and children need to be concerned?
Well, mercury is surprisingly noteworthy, especially when you see what's been done. You mentioned things there, but actually a lot of that, like the mercury thermometer is now historical. You can't buy one.
Right,
it's
a glass
been banned.
one. Yeah.
And switching, all the switching, the silent switches, the thermostats, just about everything has now been banned. And the chlor-alkali plants have been closed down. These used a lot of mercury. In fact, just about everything except coal combustion, cement factories put out a lot of mercury, and metal smelters. They are the only really uncontrolled features now. And the coal is going to be controlled. And now I know people don't like coal, but actually coal can be burned very, very cleanly now if you're willing just to spend a few dollars. And we have to burn coal. We cannot stop burning coal. Half our electricity comes from coal. So people that say just throw away coal. And the other thing, of course, is some countries are turning back to coal as well. Germany's shut down its nuclear, and Japan is doing the same. So, and coal is so inexpensive and so available, there is no way we can live without coal. So we have to upgrade the plants, and that is being done. That's my job, and even if it's not my job, it will cost more, but there are other methods. They're not as nice, they're rather messy, but the mercury will be controlled by one method or another for sure. So it does look good in that way, that we are eliminating a lot of the sources of mercury. And eventually, I would think it has to start showing, especially now that we have also taken mercury out of many of the vaccines, it's still present in a few, that we have to start seeing some change. My own personal feeling is there's a little more to it than that. And that is, there is, as the doctors say, a genetic component. It's only one component, but it's a major component, in that some people are more susceptible than others.
To feel the effects of the mercury poisoning, of a heavy metal.
There are some people cannot get rid of mercury and other trace metals. There are some wonderful studies.
I think I'm in that genetic pattern.
Well, there are some wonderful studies when they go down to They go down to a community. They find a community somewhere, like in South America or something, where all the community has a similar type of diet. And then they test the mercury levels in all the people. The thing that I don't see talked about, but the thing is the distribution of the mercury levels is tremendous. There are some people with hardly any mercury. There are some people with a lot of mercury in them. And it also reflects into some of the other metals. It's like people cannot get rid of some of these metals. And I'm talking, and the problem is with these studies, what they will end up doing, they will average all the data, and they'll come up with an average, and they say, well, the average is okay. But it's not that. It's the spread. And this spread is can be 100-fold. So some people have 100 times more mercury than others. And I think this is one of the major problems. They cannot get rid of it. The only way you shed mercury if you have a genetic problem is through your hair. Through your hair and your nails. And I think they're finding this in autistic kids.
Okay, and I've spoken to Dr. Salerno out of New York, and he confirmed a study in the Journal of the Medical Association, and coming up with, they found traces of or traces of mercury in men now from their nails. They were studying that, and it's showing up in men. So it doesn't just necessarily affect women and children, it's affecting all of us.
Oh, it affects everybody, yes. I mean, it's to a point, I think, that it would be really prudent for people who are about to be pregnant or pregnant to have their mercury level tested. Just to see what it is.
Going to, yes.
We have enough statistics now to know what is somewhat acceptable. I mean, we've always had mercury in us to some degree, but there's no doubt it has really increased in the last 20 years.
And how does one find a doctor that is educated in mercury and also a lab that tests properly for mercury, because I know myself I was not tested properly.
That's not my area, but I would certainly ask around, and in fact the web now is helpful in that way. I mean, you have to sympathize a little with the doctors, because it's really funny in a way, it's ironic that in the mid-1800s, 1900s, mercury was used for medical reasons. It was used for syphilis in the Middle Ages. They used it as a laxative. They used one compound of mercury that it's the other mercury chloride, monomercury chloride. It's called calomel. And it's, again, insoluble in water, so it would pass through your body. But they took that as a laxative, and they think, in fact, that killed Mozart, because he took a lot of that. And so, and then there were the people in industry that came down with mercury poisoning. There were a lot of people with mercury poisoning in those centuries. The doctors recognized it. That's where these chemicals, the mercaptans, were discovered, and that's why they call mercaptans mercury capture. They found only a certain chemical group, and it's a hydrogen sulfur. Mercury is hard to attach to anything except sulfur. And it's got to be one of these sulfur compounds that they use nowadays to try and chelate and flush out mercury from people. But this was actually discovered 150 years ago. They're still using one of the same chemicals today, I think.
Okay, so we only have like a couple minutes left. So time flies and we have so much to cover. What do you have to share with the viewers, the importance of it, where can they learn to more about mercury, how can they contact you if they have questions?
Well, they can contact me quite easily by email if they wish. The web is an encyclopedia nowadays. I mean, there's so much information out there, and you can get so much advice. But it is a subject where you do have to do a little research, I think. As I say, I even wonder about myself nowadays, whether I should go and, for curiosity's sake, see what
your levels are.
My level is. And the history of mercury is a difficult thing to, but if you reduce your intake, which you can do by cutting back on, the problem with fish is the big fish eat the little fish. It bioaccumulates, so you keep away from the big fish.
Right.
Tuna, swordfish, shark. You eat the small fish. Fish is very nutritious, and this is why EPA, NIH does not want to ban this fish, because it's so nutritious, but it's getting hazardous.
Less than 1% of the seafood that is sold in the markets is tested. So how accurate is that? The U.S. Geological Survey has come out with a study that they tested the U.S. waterways, and of the fish, all fish had levels of mercury, and of those fish, over 25% had the levels that exceeded the EPA's safe levels. So it's that's a very startling.
You have to be very careful, and you cannot. You have to replace fish to some degree in your diet with alternates. Yes, and particularly I tell particularly women that they should not really eat tuna fish more than once a month or something like that.
I agree.
But your body, if you're lucky, your body can get rid of it. This is the whole dilemma. Some people have no problem. It's no problem to some people. It's a little like smoking. You know, EPA is currently trying to explain why some smokers never have a problem.
Well, we have to wrap it up. We'd like to thank you, Dr. Keith Schofield, for sharing your information. We've got lots that we didn't cover. Unfortunately, we only have a half-an-hour show. And if people want to read about my story, about overcoming the mercury poisoning, having the mercury poisoning, understanding more about it, you can find Rising Above Mercury on Amazon, on my website, Rising Above It, or in the local bookstores. Also, I have the Rising Above It book, and that shows how I did it, how I overcame my mercury poisoning.
So it can be done, you see.
Yes, it can, and I'm living proof, alive and healthy.
But it's good to catch it early.
Yes.